Hello and welcome back. Good to see you again. So let's see. This lecture is going to be on Descartes and Newton. Let's start by reviewing where we left off at with Galileo in the last video. So with the condemnation of Galileo, there was a big sort of popular uprising against the university system. The humanists wanted to go out and do their own interpretation of the Greeks and their sort of own scholarly activity. And a lot of good scholarly activity came out of that. But the Copernican revolution did definitely have some problems that those humanists had to face. Namely, it contradicted the standing body of physics and philosophy at the time. And so you lost a lot. You have one thing: Earth revolves around the sun. Your explanation of the universe, you have to take it from there and recover everything else. So first, came Descartes, early 1600s, and we can think of what he did as trying to reconstruct a new philosophical system, a new basis of a standard of rational argumentation and such, in which this sort of new humanist movement and Copernican revolution could flourish. His method is something called the method of radical doubt. The idea is this: you start by doubting absolutely everything you can, no matter how crazy or stupid it seems, you doubt it. And then what you're left with is whatever you absolutely could not doubt at all. If there's something that you just cannot doubt, this now becomes the basis of your new philosophy. From this basis, you then reason off and deduce more and more things you now know. And if you're reasoning logically, then those things will end up being just as indubitable as your starting basis. Perhaps you recognize a relationship here with the axiomatic method we've studied. Philosophers have loved the axiomatic method throughout history, and Descartes can be seen as adopting it here. Now, a difference is, remember, those starting Euclidean axioms were picked as axioms because they were considered to be the most obvious and the simplest. And even that was a little shaky with that fifth axiom. People were struggling with that for millennia. And Descartes had a much higher bar. It didn't just have to be the most obvious things. It had to be the absolutely indubitable things, the things that you just cannot doubt. So what's that? What made the grade? What passed that bar? This was his cogito ergo sum. And what that says is, I think, therefore I am. The idea is, if you're sitting there thinking and doubting everything, the one thing you can't doubt is that you are sitting there thinking and doubting things. So therefore you exist. He took that as his base, foundational rock axiom, and then deduced tons of stuff off of it. This is now his philosophy, how you conclude all this. So he concluded, he was then able to prove the existence of the external world and the existence of God and all of this stuff. And he said, this is how philosophy should be done. Subsequent philosophers are unimpressed with the rigor of his argumentation, but a lot of them really appreciate his vision and his way of going about doing it. So this sort of kicks off a huge program of trying to fix Descartes' execution of this plan, if not fully accepting his actual arguments and things like that. So that was Descartes. Now, and this is a video on the history of mathematics. I should point out here that Descartes was the one who created what we now call the Cartesian coordinate plane. That is, he was the first one to get an x-axis and a y-axis, and to think of curves as being described by equations. So that came there from him. And I think I forgot to mention also, importantly, he wasn't a university professor. In fact, he was a mercenary fighting in all of these wars that were religious wars going on in Europe at the time. All right, so there's the philosophy. Next comes Newton. Isaac Newton, and this is in the latter 1600s. And we can think of what he did was as introducing a new physics to that the Copernican system was consistent with. So now you might say, we say that Newton invented the theory of gravity. You might say, didn't people know about gravity before then? I mean, didn't people observe that things fell from the sky? You know, there's this popular story of Newton under the apple tree, an apple falls and hits him on the head, and all of a sudden he realizes there's gravity, as if he was the first person to ever notice things fell. it's not that he was the first person to notice that things fell. He was the first person to understand this phenomenon in the way he did. Let's go back to Aristotle, the Aristotelian explanation we had. Remember, for Aristotle, everything was made up of a mix of four elements: earth, air, fire, and water. And each element had a natural place: earth in the middle, then water, then air, then fire. And if you take an object like this pencil, which is presumably mostly made up of earth, it will travel in a straight line towards its natural place. So if I drop it, it goes towards the earth in a straight line. And then celestial bodies are made of a different substance called the ether, and that's natural motion for that substance. Instead of a straight line motion, its natural motion is in circular motions, which is why everything goes round and round in the sky. What Newton came up with was the idea that everything obeys one law. Everything obeys one principle, the universal theory of gravity. Doesn't matter what it's made up of. And it is this same principle, this same force, gravity, that explains both the pencil I just dropped here and the sun and moon appearing, going around in circular motions in the sky and all of that stuff. Perhaps, I have no idea if that apple story is true, but I think a more philosophically accurate version of that story would be if he were sitting under that apple tree at night looking up at the moon and the apple fell on his head. And suddenly he had the realization that the same thing that is dictating the motion of the moon dictates the motion of the apple that just fell on his head. That is all the result of one single force. So that was really what he brought to the table. In addition to this, he developed a whole new mathematical system called the calculus in order to describe and explain and calculate and prove all of this stuff. Now, the calculus is a great step forward in our calculating powers and being able to do these things. We will look at the calculus in more depth in the next video. The way he did it is not necessarily the way you saw it in high school or college if you've seen calculus. He did something called the infinitesimal calculus, and that's going to interact very interestingly with all of our concerns about infinity in this video series. So we'll get to that in the next video. Also, although this was some great unifying ideas. Again, remember how we said the Copernican system was great because it simplified the motion of the planets. And the Ptolemaic system, we had the Earth and the sun going around the Earth and planets going around the sun, and so they're traveling like this crazy. In the Copernican system, we have the sun in the middle and planets just traveling around like that, much simpler. Also, so in the Aristotelian system, we had all these four elements, these natural places. Everything's moving to its natural place. The fifth aether in the sky, also dictating a new motion. Newton boiled it all down to one force, gravity. So just like the Copernican system was a huge simplification of the planetary motion, Newton's physics was a huge simplification of the physics known at the time. So that was great. However, his new system was not without its detractors, even among the humanists, even outside of the academic system. Now, remember, going all the way back to Plato and Aristotle, there's been this debate over rational thinking versus mysticism. Abstract mathematical objects entered into Western thought through just out-and-out mysticism of the Pythagoreans. Plato was perfectly comfortable with mathematical objects being otherworldly, and we experience them in our trips between lives and reincarnation. Aristotle, on the other hand, just didn't like that idea at all. He said abstract things are less than a shadow, that rocks are what are really real. Abstract things are hardly any existence at all. And every generation of scientists or philosophers or whatever, it seems like, the next generation is accusing the old of mysticism, and they're going to come up with the real way of rigorously, rationally looking at things. And this happens again and again and again. This will now also happen going from a conflict between the followers of Descartes and the followers of Newton. So for Descartes, he put forward that a scientific explanation is one that explains phenomenon simply in terms of particles colliding, like no occult forces. Sounds reasonable. So for example, he would explain heat as the particles of the hot object either wiggling in place really hard or even colliding with each other, or like in a gas going all crazy all over. It's that motion of particles which explains the heat. He also explained magnetism in terms of the magnet sending out millions of microscopic little screws that drilled into metal things and pulled them towards the magnet. So for example, imagine if I had a block of wood and a screw, and I put the screw into the block of wood. Now I held the screw steady and twisted it. If I held the screw steady while I was twisting it, the block of wood would move towards the screw. See? The magnets are throwing out these little screws that are spinning this way much more quickly than they're moving that way, so that when they hit the metal, it pulls the metal towards the magnet. I've got a book whose cover has a picture of this. So here's a picture of the Cartesian screw theory of magnetism there. You got a whole bunch of little screws making sort of the magnetic lines of force there. That is a scientific explanation. And Newton introduces now a force at a distance, what his detractors would call an occult force, this gravity. They said that he is reintroducing occult forces into science. Now, Newton's response was, "Fingo non hypothesi." I put forward no hypotheses. Newton said, I am not saying this is an occult force. I am just observing it and recording it and using these observations and recordings to predict it. Use it to make predictions of like when planets will be or when eclipses will be. And it worked great. So there's a disagreement over what it means to be scientific. For Descartes, for something to be scientific, it needs to explain a phenomenon in terms of particles and collisions, in terms of rational ideas. For Newton, to be scientific means to just describe the phenomenon, not necessarily explain it, but describe it in a way that's able to use it to make predictions about the world, and that is what it means to be scientific. And eventually, Newton's view of science became the predominant one. It kind of won out. So this whole screw theory of magnetism was eventually abandoned. Also, though, the particle motion theory of heat was abandoned in place of a Newtonian theory called the caloric theory, which didn't end up panning out. And this illustrates a good point. When we have these changes in science, what we might call a scientific revolution, first of all, they're not always rational. They can be propelled by social forces. So we talked about the humanist revolution being sparked off by the Pope's condemnation of Galileo, not necessarily people looking at things and making the most rational decision of which one was the better one. I mean, at the time of Newton, think of how much you had to lose. Was it really worth the mathematical simplicity of his model? And also, in this time, you got Descartes versus Newton, pretty much. You had a generational turnover. The old guard was retiring or passing away, and you had a new guard coming in, excited about the new ideas. And so this generates a scientific revolution in which there are some gains, but then there are also some losses. It's a very messy and a very human process, and that is how science progresses. Now, here's just an interesting sort of human point. Although Newton said "fingo non hypothesi," in his personal journals, which were published after he died, he did say personally he believed that gravity was the result of constant interaction of God with the physical universe. That is, remember way back when we said the scholastics would not accept an answer for why does it rain of God wills it? Well, that's basically Newton's explanation of why do things attract towards each other. Newton personally believed because God wills it. So that is where that comes from. Let's see, where are we? So what have we just done? Last couple lectures, we have breezed through 1,800 years of history. We talked about the kicking off of the humanist revolution and now the scientific revolution and the sort of removal of intellectual thought from the university church system. And we noted the beginnings of the theory of gravity, modern philosophy, and the creation of the calculus. This next lecture, this next video, we'll look more closely at the calculus. And like I said, it's a great calculatory leap forward. It's a great advance and really tremendously helped science. Don't want to underplay that. You can't understate what a great advance it was. But in the context of this video, where we have some more philosophical concerns and we're motivated by themes like the problems of infinity and how are we to rationally and consistently understand how infinity works and our relation to it, Newton's introduction of the infinitesimal calculus was problematic. We could say it made matters worse instead of better. So you'll see that when we get there. See you then. Thanks.